Okay, today we're doing lesson 7.8. Compare mixed number, factors, and products. Remember when we compared our fractions, if they would be, if the product was less than or greater than our factors, without a mixed number. Now we're going to talk about it with using mixed numbers. How does the size of the product compare to the size of one factor when multiplying fractions greater than 1? What you need to remember here is what's the product. What's the definition of product? Okay, and what's the definition of a factor? One of the numbers that you multiply. Okay, so don't forget those things. Unlock the problem. Okay, at the very top of your paper under unlock the problem, it says you can make generalizations about the relative size of a product when one factor is equal to 1, less than 1, or greater than 1, right? If the one factor is equal to 1, what's that going to mean for our product? That it's going to be equal to the other factor, right? If we multiply something by 1, the answer is always that something. When the factor is equal to 1, less than 1. If we multiply something by less than 1, then our product is going to be less than both of our factors. If we multiply by something greater than 1, then our product is going to be greater than our factor. Okay? Here's our problem today. It says Jane has a recipe that calls for 1 1/4 cups of flour. She wants to know how much flour she would need if she made the recipe as written. Meaning, if I had a cookie recipe and it called for 1 1/4 cups of flour, if she made half the recipe, and if she made 1 1/2 times the recipe. So maybe I'm making cookies and I'm just keeping them at home and I don't need very many because we don't need to eat very many cookies, so I don't want to make half a recipe of cookies. Or I'm going to take my cookies to a party and so I need more than usual, so I would make my recipe 1 1/2 times larger than is written on my recipe card. And don't think this doesn't happen, because it does. I do it all the time. A lot of times I get a recipe and I think, man, that's a lot, and there's only 2 of us, to eat it at my house. So I have to cut that down in half, or I even do it with pudding that you buy in the box, because we don't need to eat a whole deal of pudding, and we like to make the cooked kind of pudding that's hot, and then put some Cool Whip in it and have that for a snack.
Yeah, since we eat a lot, we usually don't eat it.
Right. So there's times when you'll need to use that, depending on the size of your family. Shape the model to show 1 1/4 scaled by 1. I'm not sure why my computer keeps freezing up. Okay, so you need to take your little squares. Your first one on A, you're going to leave it whole. The other one, you're going to divide it into 4 equal parts. Why?
Because there's
We have
1 and
1/4. So go ahead and do your boxes. The first one, leave it whole. The second one, divide it into 4. Then our question is, what can you say about the product when 1 1/4 is multiplied by 1? They give you a little hint here. I can use what I know about the identity property. What does the identity property say? Any number multiplied by 1, then the product is always going to be that number. So the product will be equal to 1 1/4. The product will be equal to 1 1/4. Okay, this is your part B, and we're still working with Jane's 1 1/4 cups of flour. Now she only wants to make a half of a batch. So shade a model to show 1 1/4 scaled by 1. So this time you're going to divide each of your squares into 4ths, each one. And you're going to shade 1 1/4 of your model. So you're going to shade one hole over here on the left, And you're going to shade 1/4 here on the right. Make sure you shade the 4th next to your 1. Okay? And that should be all the same color. Here's your thing. It says the product will be half of what I start with. So now we're going to divide these in half. Each of our models, we're going to divide it into half. And we're going to shade 1/2 of our picture a different color. So shade the top of it a different color. Your second color that you have. Okay, so then what can you say about the product when 1 1/4 is multiplied by a fraction less than 1? What can we say? That the product will be
less
than 1 1/4. We can say that the product will be less than 1 1/4. Why is that? We're multiplying it by another fraction, so we're taking only part, right? If we multiply something by a fraction, we're taking only part of it. Okay, and this is C at the bottom of the page. Remember that Jane was going to make her original recipe, and now she's going to say, shade the model to show 1 1/4 scaled by 1/2. So we have 1 1/2 times 1 1/4. So 1 times 1 1/4. So the first thing you need to do is put a line in this. Divide this one into 4ths. Okay, now we're going to shade 1 1/4 of that with one of your colors. So 1 whole and 1/4. Okay, we're taking our recipe 1 1/2 times. So here's 1 time. Now you need to go over and divide your other model into 4ths, all the way into 4ths, each box. And we're going to shade that in just like we did this one. So use that same pencil and shade it in just like we did that one. So this model over here represents 1. The 1 times our recipe. I'm sorry. The 1 in our 1/2. And this model is going to show half of that. So divide your little boxes in half. Then you're going to need to get your colored pencil of another color. And you're going to shade half of it. So we have 1 of the recipe, and on this side we have 1/2 of the recipe, right? Shaded double color. So we're looking at this and this, much that we shaded. So what can you say about the product when 1 1/4 is multiplied by a number greater than both factors? The product will be greater than both factors. Then if we multiply a product, 1 1/4 is multiplied by a number greater than 1, the product will be greater than both of the factors. Okay, let's move on. Okay, now we're looking at another way on page 322. And let's just do a little reminder here. It says you can also use a diagram to show the relationship between the products when a fraction greater than 1 is multiplied or scaled by a number. And here is our little problem. Jake wants to train for road race. He plans to run 2 1/2 miles on his first day. On the second day, he plans to run 3/5 of the distance he runs on the first day. And then on the third day, he plans to run 1 2/5 of the distance he runs on the first day. Which distance is greater? The distance on day 2, when he runs 3/5 of 2 1/2, or the distance on day 3, when he runs 1 2/5 of 2 1/2. So here we go. We are going to think about this. It says locate 2 1/2 on the diagram and shade the distance, which they did in pink, and graph the point that shows 1 times 2 1/2. And so that is going to be equal to 2 1/2. Now we're ready for part B, where this is the second day, where he only runs 3/5 of what he ran. So we're going to think, and we're going to locate 2 1/2 on the diagram and shade that difference. And then it says, and shade that distance, then graph a point that shows 3/5 of 2 1/2. So if we look at our 2 1/2, we have 5 spaces in it. So we are going to do shade out 3/5 of that. So our dot would be 1 2 3/5 of that. The product of the number less than 1 and 2 1/2 is less than 2 1/2. Now we're on C, and we're going to work with his last day. And remember, on the last day, he's going to run 1 2/5 of his 2 1/2. So we're going to look at his thing, and we're going to again locate 2 1/2 on our model here. And then it says then graph a point that shows 1 of 2 1/2 and 2/5 more. Remember, we established before that each of those marks is a fifth. So if we were doing 1, we would say that this was our point for 1, and then we would have to go 2/5 farther, so we would be at 3 1/2. So the product of a number greater than 1 and 2 1/2 will be greater than 2 1/2 and greater than the other factor. So 1 2/5 of 2 1/2 miles is a greater distance than 3/5 of 2 1/2 miles. And we should know that because in this one we're taking the whole distance plus a part, and in this one we're just taking part of the distance. Let's go on to the share and show. This is at the top of the page, and you're going to divide your models into 1/5, and then you're going to divide them across in 6. So I have shaded my model across in 5ths, and I can show 2 1/5. And then I will come back and divide my model into 6 across. And since I'm multiplying that by 2/5, I will then, or 5/6, I will shade in 5/6 all the way across. So the double shaded area is the product of 5/6 times 2 1/5. So you can see we have some bluish green left down here. So it will be less than